I am Richard from Seneca Learning, and today we're going to look at an introduction to sequences. So let's get going. So, first worked example. What are the first, second, third, and 10th terms in the sequence n squared minus 3? So, n squared minus 3 just represents a sequence, and what we can do, we can substitute different values of n to show that the different terms of that sequence. That is the first, second, and third number in that sequence. So let's start by finding the first term in that sequence. So we put in n equals 1. 1 squared subtract 3 would give us minus 2. So that's minus 2 would be the first term. Let's think about the second term. Again, substituting n equals 2. So 2 squared subtract 3, which equal 1. The second term. Third term, again, you substitute in 3 instead of n. So 3 squared minus 3, which gives you 6. And lastly, the 10th term, 10 squared minus 3 is 97. So we've got the sequence here, n squared minus 3, and that would be equal to negative 2, 1, 6, ... The 10th term would be 97, and it would go on forever. So let's have a look at some questions now. So fill the gaps in the sequence. 3n squared subtract 2. So we've got 1, 2, 3. We're looking for the fourth digit in a fourth term in that sequence. So we put in n equals 4. So 3 times n squared, so it's 4 squared in this case, so 16 times 3 is 48. Subtract 2 would be 46. Oops, 46. That's it. Next question. What is the third term of the sequence n cubed? Might subtract 12. So I know that n cubed for 3, so 3 cubed would be 3 times 3 times 3, which is 27. Take away 12 would give me 15. So the fifth term of the sequence of a sequence is 24. What are the 6th, 7th, and 8th terms if the recurrence relationship is un plus 1 equals un plus 4? So what this means is u is the sequence here. So it means whatever term you're looking for, the term before plus 4 is what we work with. So if the fifth term in the sequence is 24, we're trying to find the 6th. We've put in the 5th term here, so 24 plus 4 would give us the 25th term. So 24 plus 4 would give us 28 in this situation. And here we just work through the example. So then when we're thinking about the 6th term, we put in what the 5th term was again. So the 5th term was 24. So we put 24 plus 4, which equals 28 for the 6th term. 7th term, put in the 6th term, which is 28, and we add 4. So 28 add 4 would give us 32 as the 7th term, as shown here. With the 8th term, we put in the 7th term, and we add 4. So here we've got 7th term add 4, so 32 add 4 would give us 36. So here, the 5th, 6th, 7th, and 8th terms would be 24, 28, 32, and 36. So let's look at some questions. So if the third term of the sequence is 15, what are the fourth and 5th terms if the recurrence relationship is un plus 1, equals 3 times un plus 5? So the third term is 15. So to find the next term, we put that into this un equation. So 3 times 15 is 45. Add 5 would be 50. Let's work through the example. So u to the 4, the fourth term, equals 3 times u to the 3, the third term, plus 5. u4 equals 3 times 15 plus 5, which equals 50. Write down the formula of the 5th term. So 5th term equals 3 times the 4th term, add 5. Substitute in the 4th term, u5 equals 3 times 50 this time. So we take it from the fourth term up here, add 5, which equals 155. If the third term of the sequence is 5, what are the fourth and fifth terms if the recurrence relation is un plus 1, un plus 5? Now that's quite similar to the previous question we've had, so I'm just going to skim over that, but you just put in the previous terms to work on to the next one. So if the fifth term of a sequence, what is the fifth term in a sequence? N squared plus 5. So n squared, we want the fifth term, so 5 squared is 25, add 5 is 30. If the fourth term of a sequence is 3, what are the fifth and sixth terms if the recurrence relationship is un plus 1 equals un, subtract 2? So if we want the fifth term, we take the fourth term and take away 2. So the fifth term would be equal to the fourth term, which is 3, subtract 2, which will give you 1. And then if we think about the sixth term, we're going to take the fifth term and take away 2 again. So the sixth term equals 1, subtract 2, which equals negative 1. And that is the end of our introduction to sequences, 94%. Fantastic. See you again soon.